All right, so I'm going to be explaining triangle silver explanation. I was meant to do this on LiveSolve, and I had the recording, but the funny thing that happened was the recording kind of like cut out something, and like I didn't feel like re-recording or re-doing the implementation. But yeah, so the first time, just warning, the first time I did this problem, like on the LiveSolve, um, which I'm not uploading because it got like ruined. I forgot to do answer mod, so I almost got it on the first try. I just forgot to do answer percent mod, and so I only got the first 5 cases. That's why. But without further ado, let's just explain the implementation. So this is going to be a pretty easy implementation to explain. As long as you understand the logic, I recommend you to implement it on your own. But there's always it's always good to see other people's implementations, I guess. So this is my own personal implementation of triangle silver. So here I just have a static class cow, which implements comparable cows. So we're just using comparators. And the idea here is each cow will have an ID and an X or Y value. So I'm not going to explain anything because I've already explained this problem, right? But in the last video, if you look at that triangles, so we actually explain the logic. But the thing is, each cow will have an ID. So essentially, an ID is like the number. So if I saw cow 0, when we take in the input, we'll pass I as the ID to represent the cow. Like if to represent that this was the 0th cow that we saw. This was the first cow, and so on. And this is important because we need to refer to a cow's ID, or you can call it an index. I call it an index. We need to recur to a cow's ID or index when we make the sum of the bases and the sum of the heights array. So that's why we have to do that. So then we have xy to represent uh, the y or x value that we're going to pass in. We have n to represent the amount of cows. We have this long thing, right? And then we have a hash map, right? I'm mapping an integer, which is going to be x, right? So I'll map x to a list of cows. I'll map a y to a list of cows as well. Remember, we're fixing an x. We're fixing a vertical line for map x, and we're storing all the coordinates that lie on that vertical line, and we only need to store their y values because we already know their x values, right? That's the thing that's actually being mapped. That's a key. So, and that's why we only store one x or y depending on if it goes to map x or map y. And then we have these two arrays, sum of the bases and sum of heights, which says the sum of the bases at a cow I, or which a cow I is described by the index we pass in the comparator. The sum of the bases at a cow I represents the sum of the bases at that fixed point, like in the logic. And the sum of the heights is the same idea. And then we have our long answer. Make sure this is long because you don't want to overflow. And then taking the input, right? And then after, what we do is we have to say, if we have not seen this x value, let's actually make a new, let's put this into the map so it's not null. And then we add that new cow. Else we just add it, and we do the same thing for y, right? We're creating the maps that we talked about in the logic. After, we just iterate through every single x value in the map, and we make the cows and we sort it, right? And remember, we're not sorting the n cow, so don't think this is like n. Don't and also we're not doing n times n log n because we're just going through it. Because remember, each list is not like n, so don't get this is still like in time. Don't get confused by that. Like, remember, we're just gonna sort the cows, right? So in the map, we need to sort it by the value, right? We're sorting it by value. If they have the same thing, I don't even think it matters here, but whatever. We're sorting it by this value. And so we can start using the logic, right? We define s of 0 as the distance from the point 0, the earliest cow, which is cow does get 0, which is why we have to sort it. And I forgot to mention, if the size is 1, we don't really care because um, like you can't get the sum of the bases is just 0. So yeah, if there's only one cow, there's no way you can form a base. For a base is defined as 2 points. Pick any two arbitrary points and draw a segment to them, right? In this case, we want them to be on the same line, but the idea is that you obviously can't form a base with 1 point. So we define s sub 0 as this, and then what we do is this is our base case, and we use the recursive formula like we talked about. And now, yes, there is a much cleaner way to, oops, okay, there's my laundry. Hold up. Okay, it's done. And there is a way to compress this formula algebraically. You could just factor out the x sub I plus 1 minus x sub I. But the reason why I didn't do that was because logically, if you look at the algebra, the cleaned up solution, the cleaned up expression, which is, I think, if I remember correctly, it's s sub I plus 1, actually 1 and 0 index, so I'll just do this, is equal to s sub I minus 1 plus 2 times I minus n times xi plus 1 minus xi. So the reason I didn't do this was because like if you didn't group the terms, like factor by grouping, like if you didn't factor this piece out, it's kind of just hard, like staring at this formula. It's pretty hard to like understand what you're doing. If you leave it in this formula, you can see, oh, I'm this is accounting for all the cows on the left, and this is also accounting for all the cows on the right. So that's what I did, it just to make myself understand more. And like, yeah, but I guess it's cleaner to do this honestly, but it doesn't really matter, same thing. um, we do this for both x and y, right? Some of the heights and some of the bases, because the reason why it's some of the heights for x is because we're fixing a vertical line, thus its heights, and for y, we're fixing a horizontal line. After that, we go through and we do answers, right? Some of the bases at I, some of the heights at I, where I represents a cow. And make sure to just mod everything. Like, I forgot this small bit, and I only got first five cases. Then I figured out, oh, I'm pretty dumb. I forgot that. So just make sure you mod everything throughout your code. Like, even if you don't think you need to mod, just mod it. Like, yeah, it doesn't hurt. Just mod. So yeah, that is the implementation. Pretty quick.